I'm Wani. I'm going to introduce new terminology, treatment effect, today. Treatment effect is important concept in ANOVA. Before introducing treatment effect, I'd like to review a little about structure of a random variable X. Let's see again. A structure of a random variable and modeling. Okay, we have random variable. Random variable is mean mu plus epsilon. Okay, mu is mean of random variable y, and epsilon is error follows normal distribution with mean 0, some variance sigma square. Epsilon is a random variable, so y is random variable. Epsilon follows normal distribution, then y also follows normal distribution. You understand that? It is a basic structure of random variable y. But this assumption is pretty natural. Okay, you just accept the this assumption. I mean, error follows normal distribution with a mean 0 and variance sigma square. Okay, let's see treatment effect. To perform statistical analysis, a model to which the analytical techniques can be applied is assumed. A model assumed. We have such model. Then we follow the steps, statistical techniques. In other words, for a particular analysis, one assumes the structure of data, estimates the parameters, unknown values of that structure, and performs hypothesis testing in sequence. The analysis of variance model used to test whether there are differences among the means of k independent groups, and well, the model is going to be mu ij equal to mu I plus epsilon ij, I from 1 to k, j from 1 to n. You get their k populations. This one y1, y2, yk, random variable, and they are mu1, mu2, mu k, and also we have 1, 1, 1, n sample from population 1, and y21, 22, y2n sample size is equal from here yk1 up to ykn. These are samples, okay? So in one line, yij sample is from mu I. Its mean is mu I plus epsilon ij. I from 1 to k, j from 1 to n, okay? This is a simple expression of these diagrams. Assumption. Epsilon ij follows normal distribution with mean 0 and variance sigma square. For example, let's say we are testing hypothesis that weekly working hours, Y1, Y2, Y3, three, say, companies of workers in their 30s employed by three specific companies, A, B, C, are the same. Okay, weekly working hours are same. The null hypothesis is going to be H0, mu1, mu2, mu3. At this point, let the mean of all workers in their 30s through three companies be denoted as mu. The mean of all workers in their 30s, okay, three companies, mu. What is mu? Mu is this. There are three companies, A, B, C, and weekly working hours, mean of three companies, mu1, mu2, mu3. But all of them, working hours, mean of all workers in the three companies is mu. Okay? Get it? And we define alpha 1 equal to mu1 minus mu1 minus mu. Alpha 2, mu2 minus mu. Alpha 3, mu3 minus mu. Okay, it is a kind of a not trick. It is say tips where alpha I represents the difference between the mean of ith company and the overall mean mu. Okay, which can take a positive value that can be positive or negative values. This is referred to as unique effect or treatment effect of ith company. We call alpha, okay, unique effect or treatment effect. If we express the analysis of variance ANOVA model in terms of treatment effect, then mu y ij equal to what? What is mu I? Mu I is mu plus alpha I, mu plus alpha I, right? Plus epsilon ij. So this model can be written as this way. Then we express the model with treatment effect. Understand? So it is not that uh, difficult, I think. Okay, let's see. Then the null hypothesis, what was the null hypothesis? Mu1, mu2, mu3. So mu1 is what? Sorry. Alpha 1 is mu1 minus mu. Alpha 2, mu2 minus mu, right? Alpha 3, mu3 minus mu. So if they are same value, equivalent, then alpha 1, alpha 2, alpha 3 should be equal to 0. So that null hypothesis can be written, expressed as this way, equivalent. Here, the treatment refers to the three company A, B, C. In this case, the issue of performing an ANOVA is to determine whether there are differences in working hours among the three companies, correct? However, if we also want to investigate whether there are differences based on gender, in addition to the differences between companies, say we like to add one more thing, gender issue, then we have two factors, company, one, two, three, A, B, C, okay, one factor, and second factor is going to be gender. When additional factors are included, we need the model that represent the treatment effect of each factor for use in analysis of variance. Then we call it two-way ANOVA. When there is one factor, say in this case, company, different company, ABC, it is referred to as one-way ANOVA, one factor ANOVA. Usually many person says one-way ANOVA. And when they are two factors, one is the company, the other one is what? Gender. It is referred to as two-way ANOVA, two-factor ANOVA. Of course, if they are three factors, then three-way ANOVA. I have experienced many person try to have two factor. Sometimes they want to have three factors, but I never seen four factor analysis. So it's going to be more complicated, okay? But we are going to study up to two-way ANOVA, okay? That's it today. Thank you. Bye.